test. Okay, let's get started. And you want to say something as well? Yeah. Okay, welcome everyone. Let's get started. Welcome on this rainy and cold day, the first of many to come. Welcome to the Go Meetup at Cloud Pirates. I will start with some introduction slides, well, the basic stuff first. Join our Slack, and if you want to become a speaker, please tell any of the organizers. We're always looking for more speakers. Lightning talks, full talks, if you want to do a quiz, if you want to do whatever, everything welcome. If your company wants to host an event, that would also always be nice. We're always looking for more hosts. We're also looking for sponsors, because we give out mugs and chocolates and stuff every time. Or if you even want to become a co-organizer, if you're thinking like, yeah, let's help these guys, they suck at organizing this, then welcome and come to me or any of the other organizers. Today, the agenda, we start with generics in Go by Pavel. Then we go to cucumber testing by Koen. Then we have a break. Then we do reproducible builds from Michiel. And then concurrency patterns by Ilya. We also have another speaker all the way from the US. I don't know where he is now. He will do a talk about, what was it? The Azure CLI. But I will adjust this slide later. Oh, wait. Yeah. The next meetup, well, this should be at the end. Sorry. I'll say that later. First, let's hear a little bit from our host today. You can, well, yeah. Alessandro, thank you for hosting us today.
Hey, welcome to the Golang Meetup, to our humble co-working space, cloudpaddles.nl, because we are the paddles of the cloud, like the paddles were the freelancers of the sea. We're all a bunch of freelancers and rogue engineers. I'm also the organizer of the Dutch Kubernetes Meetup, so if you want to talk about Kubernetes, if you want to borrow the book, or if you want to get your 3D printed gophers, just find me out and I'll be happy to connect to you. We also organize a conference in Amsterdam called Kubernetes Community Days, so if you want to, the call for paper is open, and if your company wants to help us, we are very welcome. I'll just leave some flyers over there. And well, that's it. Thank you very much.
Now it's my turn. I hope you can hear me well. If no, then, well, bad for you. Anyway, my name is Pavel, and as you might have guessed, I will talk about generics. The plan is that I will show you just the simplest part of how to use it. Then we will check out some benchmarks, and then we will have some time for you to ask questions. And I really hope we will have, so I will try to be fast. The first one is this topic, like we don't need generics. This was really literally on fire when generics weren't even a proposal. So, well, let's check out what alternative do we have. First of all, manual monomorphization. Well, it's basically just a copy-paste, actually. Like when you copy your function and change the type, it's a manual monomorphization. So here is a new word for you, for few of you, I hope. Anyway, it's an easy thing. It works fast. Yeah, it works fast, but it's hard to handle. Like when you have multiple functions and you need to change one of them, you need to change every one of them. You need to don't miss anything. So yeah, it's bad. We can use interfaces, but it's an additional layer of virtualization, so it's a bit slower, and it also needs some checks, some additional checks, and it's not so safe, and we lose our type strict connections between our functions and types, so it's also not an option for me. We also have reflection, like a more flexible instrument, but in the same time more complicated, and even, well, at least 10 times slower than interfaces. We must use it in some cases, but in general, it's not the best option. And the last one, but not the least, code generation. For me, it's one of the best options because we have the speed and we have like a function and we have type safe of Go. So yeah, it's good. And basically, generics are kind of first, syntax is way simpler than some code generation stuff. You just have these square braces when you set your type parameters list. So it's just a set of types, type parameters for your usual parameters for your functions. And you also have to set constraint for your type parameters, which adds some bounds for the types for function parameters. Let's first check out unconstrained generics. Like if we set no bounds, we can use a new word any. It's just a synonym for interfaces, and it leaves us no bounds, so we can take like last element of slice or reverse slice. Like eventually we can reverse any slice. But if you want to implement functions like less or any other arithmetical functions, you are going to fail with these restrictions because Go compiler will check like is this function safe? And it's not safe because you can't put any type there. You can't compare like maps or something like this. So you need to use constraints. For example, this is a built-in constraint comparable. It's now in the standard library, and you can use it for functions like less, more, or any other number of functions, for example. So as you can see, you can constrain generics by types. You can use already familiar interfaces, but now not for functions list, but for types list, and set any type you want to use in your function. You also can set it just inside the function without introducing a new interface. And you may notice a new tiny thing here, a new symbol. So what's this? It's a new token. It's actually, if we set this token in front of new type, it will denote the set of types whose underlying type is this type. An example, if you introduce your custom type with underlying type, for example, uint64, you will be able to use it in generics functions, which have the constraints like this with this new token. So, well, pretty useful. You can use your new types with some generic functions, which usually would work only with built-in types. Another way to bound generics, to constrain them, it's interfaces. As you may guess, like if you can use interface with set of types, you also can use interface with set of functions. So use generics instructs, obviously, and it's just, well, one of the best improvements for myself. Like you can write some algorithms for different data structures like trees or double linked lists like here and use them with any type you want. Beautiful. But I need to mention, it was mentioning that when you create a new instance of your structure, you need to set type for it. Because in the runtime, it always will be some structure with some particular type. In this case, integer. So it's not, there are no virtualization layer. It's just a strict typing, and it's fast. So it's a good thing to have. You can do the same with functions, but it's not needed for the most of cases because Go compiler can infer the type of function you want to use. Like if you pass an int to this function, obviously you want an int function for this. And compiler helps you this way, and you don't need to set it there. So now to the more interesting part, benchmarks. I already saw benchmarks on general speed on the internet, and if you want to check out, you can Google many of them, but still, let's check them out just to know all the details. So it contains function for to check if the slice contains some element. As you can see, reflection is pretty complex, and I need to say that it's not a universal function. It can't handle everything. It's still like not finished, and it's already this size. So let's check out how much time it will take. As you can see, reflection is way slower than native types or generics. You also can notice that generics are slightly faster than native, but it's just from time to time. Practically, they are equal, and if you run it multiple times, you will have the same result for native function and for generics function. I also did a testing with Fibonacci, just in case we have like some virtualization layer, and if we will have multiple function calls, then it will be slower, but in result, no, we don't have it, and generics are as fast as native function. Next, compilation time. Actually, I didn't saw any benchmarks like this on the internet. Maybe they are there now, but when I checked a couple of weeks ago, they weren't there. So we also want to have the fast compilation of Go when we use generics. So let's generate 10,000 of functions, and I generated 10,000 functions like this, like max generic 1, 2, 3, and so on and so forth. And the same one for static types, like max int 1, 2, 3. So now we have 10,000 of function, and we want to see how fast it will, how much time it will take to compile it. And the first time I tested it without actual function calls, so it's just a list of functions and an empty main function, which just like println hello world or something like this. And it took 3.5 seconds for static types and less than a second for generics. So I was wondering why, and the answer is that compiler will not compile generic functions which aren't used. So it will compile an additional function for every type, but if you don't use it, then it doesn't compile it. So yeah, you can actually potentially have faster compilation with generics, but I don't think it's a real-world example. Like if you wrote some function, you will actually call it. So let's compare is with the function calls. So now I tested it with 10,000 function calls, and as you can see, generics are a bit slower, less than 5%, but still. So it's a little overhead. I think we can pay this cost to have generics. Whoa. So another important thing about performance. Actually, generics are like monomorphization, but not completely. And for built-in types and structs, it will generate function for every type, for every structure, and like this. But for interfaces and pointers to structs, which is important because it's also about methods of our structs, it will generate function per GC shape. I will not tell you what it is because it's a long talk and I'm on Lightning Talk, but I will tell you that Go in runtime built a dictionary with these GC shapes, and every function call will take a look up in this dictionary to find these functions. So here we will have an virtualization layer, and it will be slower, but not much. I found an interesting article on the internet. Generics can make your Go code slower, which I don't agree. I would rather name it generics can make your Go code a little bit slower, because well, it will make your Go code slower only if you just call functions, and this is it. If your code not only call functions, but they'll actually do some useful job, it will make your code just a little bit slower. This QR will be with you until the end of slides, and it's a link for this presentation. You need to skip some slides to get to those links and to click it to actually check out this magnificent article. I actually really recommend it. It has some interesting assembler explanations and some other things. So just as a conclusion, when to use or not to use generics. You should use generics to not repeat yourself. So as a conclusion, try not to use generics until you start to repeat yourself, because otherwise generics will be everywhere, and well, it's just not necessary. If you want some articles to read, I also have a list, so please check them out if you're interested. And well, that's all. Now I can thank you. Now, if I have time, I can answer some questions if you want to. We have a microphone for it, so please raise your hand and.
Just repeat the question.
Okay, I can repeat it. Please ask. Yeah, you.
So compilation time and so on, then I would assume that also matches the size of the binary that's returned. Is that correct?
Repeating question. Compilation size also binds the side of the binary. And yes, it's true. For generic code, binary was smaller because it doesn't have all these function codes. Yeah.
Anyone else? Just repeat the question.
Okay, then please ask.
Do you know of any anti-pattern that you can run into with using generics?
Okay, so do I know some anti-patterns for generics? Obviously, as I mentioned, you better think twice before you use generics with methods or with interfaces, so it may be kind of anti-pattern, but I don't know any other anti-pattern for generics. Maybe it's just worth saying that they will not solve all your database issues with GORM or any other ORM like this, because they are not they're not made to solve these issues, so just don't try it. But no, I don't know any other anti-pattern. Okay, here we go.
There was the squiggly line, the tittle, that was used to signal that.
Oh.
Look, it works. There was the squiggly line, the tittle, to signal that you could use types which underlying type had one of those native types. Do you know why there's specifically the tittle to signal that and why it's not by default? And is there any reason to not use the tittle when you add a type to like your constraint?
Sorry, I think I don't understand the question. Like, why you don't use title to
the tittle, the squiggly line. So it's like if you go to one of your slides with the constraints, it shows that new.
Okay, I'll try.
What was it? The new token.
Oh,
that one.
The new token.
That one,
yeah.
the tittle, yeah.
Oh, yeah. So the new
So
token.
is there any reason to not use it? And what would be the reason that it's not by default that my uint always satisfy the additive if it's like backed by a uint?
Well, actually, in terms of usage, I don't see any reason not to use it by default with every type. Like, why not? But maybe it slows down compilation type. I don't know. Or, well, actually, it's a good question. I'd rather want to have it like by default to use it with built-in type with my custom types. I don't see any reason not to use it. Maybe there is a reason inside, but well, we need to find out.
I have a question also about the constraints. Why am I not allowed to define a slice of something as a constraint?
You are allowed. You can, well, not like, actually, there is a great example for this type of constraint in the, sorry, something this clicker, in talk from, almost, in talk from Ian Lanes-Taylor and Greisamer. They have a talk on GopherCon, and they showed this exact example with the constraint for the slice. And it has some, I don't know, tricky parts there. So if you're interested, you need to check it out.
Okay, thank you.
It's just at least 5 minutes to really open this topic.
Any other questions? No? Okay. Koen, up to you.
Thank you very much for your questions.
Test, test, test. Hello, hello, hello. Bear with me while I set up my laptop. Yes. Okay. Thank you for the nice lightning talk. Super interesting. I haven't used generics that often yet, but I can't wait to use it because it looks really nice to use and easy. Let's start the slideshow. Using Cucumber to test your Golang APIs. Okay, first a little bit about me and who I am. My name is Koen Bollen. I've been a nerd since I can remember, working with bat files, age of 11, in Windows 59, I don't know. 95. Yeah. I taught at the University of Applied Sciences with game development. Used to do game development at a small studio, made some small mobile and PC games, didn't break through sadly. Was okay. But then I got a freelance job at Blendle, which was a super fun company, a super fun startup, so I dove more into the back-end engineer side of me. Worked there for 5 years, working in Golang mostly, and some Ruby. I don't want to talk about it. I'm kidding, it's fine. And after a couple of years, 5 years, it was time for something new, and then I found Pokey. I worked with Eric, and Pokey was best of both worlds. So I worked there as a back-end engineer, but Pokey is a gaming website. So I'm back to my roots, but still doing what I find really fun. Pokey is a gaming website. It looks like this. Kids of all ages come there to play some video games. You go to Pokey, you don't have to make an account. You click whatever game, and you start playing. And whatever developers get running in a browser is suitable for Pokey. We have about 40 million unique users a month, depending on the month. During the summer, there's a school break, and apparently kids play at schools. Fun fact, in America, we see peak hours during school and less in weekends. But in like Brazil, it's the other way around. So you can judge a country a little bit based on that maybe. And what I'm really proud of is we work with over 300 game developers on a rev share basis. So we don't license in games, we really work with game developers to make the game reach as much players as we can. And that's what I really like. So yes, I'm not here to talk to you about Pokey. I'm here to talk about Cucumber and how we test our API, basically. And I learned Cucumber at Blendle in Ruby first, and also applied it on Golang, which in the beginning was a little bit difficult, but now it's perfectly fine. So I'll talk a little bit about Cucumber. I will then talk about, in general first, how can you test your API, what are the solutions, or some of them. Then why is Kubernetes, hold on. Why is, there was a Kubernetes meetup a while back here, so my brain got fried. Why is Cucumber a nice way of testing your API? And I'm sure we have some time. I'll do a quick demo. I have a project which we can make a change to. And some closing notes and questions after. If there are any, I hope so. A fun fact, when I started at Blendle, I was a game developer. And game development is rush, 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 fast, fast, fast. So I was kind of against testing in general. So the poor backend engineers at Blendle slowly converted me to the church of testing your code. And now I'm a preacher of the choir as well, basically. I think at Pokey, I'm now the dude who said, you maybe write some tests for that as well. So that's fun. But Cucumber really helped convince me because it has a lot of extra benefits. So I'll talk a little bit more about it later. What is Cucumber? For those of you who've never heard about it. It's basically a format of writing scenarios. This is the example from their website. It describes a feature. Eating too many cucumbers may not be good for you. Then some descriptions, which you can ignore. And then there's a scenario with a title, and then some steps. And this is how every cucumber scenario looks like. In this case, it's a very abstract, it's a pretty bad example. The next slide has some better. Given Alex is hungry, when she eats 3 cucumbers, she'll be full. Then she'll be full. And it's always a couple of givens, it can be multiple steps, setting up the background of the scenario. Then there's an action when something happens, or maybe 2 things happens, and then there's the expected result. That's also ripped from their website. It combines a lot of things. You can use some automated tests, but it's also a living documentation, and maybe you can even do some business logics with it. What's fun for me is it runs in almost every language I've seen, like mainstream language. At Blendle, we use it in Ruby, Python, and Golang, and JavaScript. And at Pokey, we use it in Golang and TypeScript. What was really cool at Blendle is we had a Ruby backend, which was slow, because of Ruby, sorry. And it was specifically very nice to rebuild in Go. It was very small, and it had feature tests. So we rewrote the backend in Go, and we used the same files for the feature tests. And that was our like sanity check, like it still works, yes, because it still works, which is super nice. How is this a thing that can run? What you do in whatever language you use it, and this is somewhat Golang, pseudocode. These steps, you define steps definitions for, which are basically a regular expression that will match one of these lines. I'm sorry, I stepped over the line. One of these step definition with a regular expression, and then there's some code attached to it. So whenever you run the cucumber scenario, for each step, it will find which step it is and run that code. So for this really bad example, there's an implementation where you define the is hungry, match the name, then put the name and people on 0, and set this as the active person because the next couple of steps are continuing on this context. And then in the next you add some amount to this dictionary, and then in a test you'll return an error if it's less than the fullness threshold, which I think was 3. I don't know. So for each step, you have to write a little bit of code that would execute when that step happens, basically. Yes, this is some overhead. I'll talk more about that later. If you're using Golang, it's called Godog. It's been adopted by the Cucumber organization. It's not finished yet, but it's super fast. But the API might still change a little bit. We're using it in production fine. These are maybe some better examples. This is something you could see in our documentation. The feature is an API service. This is a very simple one because code on the slide needs to be small. Given when the client does a GET request to /health, then the response code should equal 200, and the response header should be application JSON, and the response body should be this JSON blob. Yes. This is an example from a friend of mine working as a non-engineer at bol.com, and they do some of their development scenarios also in Cucumber, and there's no code attached to it. It's just a way of writing, basically. So you don't even have to execute Cucumber. It's also like a nice format. And this is from a TypeScript project we're working on, a multiplayer networking library in web browsers. And I'm introducing a new thing. It's called the background thing. That's basically steps that are executed for every scenario in front of the scenario. So you can see like a copy-paste to in the scenario. And in this case, given the signaling backend is running, if player green creates a network, it will receive an event and an ID. And that will be running TypeScript, that will be running Golang, for example. This makes sense, right? Let me quickly see, yes, perfect. Now, the whys, because this is how it works. Not that special, actually. Now the why. Okay, one step back. Who here tests their APIs, like with automated tests? See, 4 or 5. That's a really good answer. I like it. It's good. I'm happy. Cool. Does it look a little bit like this? Using the default Go tests. So you have Go tests, which are, by the way, awesome. Like, that's one of my favorite things about Go. You set up a request and a recorder, a response recorder. Then you have your in-memory store and your mock client for some service. You add some data to your mock store. Then you create your HTTP handler, and then you fire the request, and then you'll check the result of that. In this case, I'm only checking the status, but then you have some helper function to check the JSON or something, right? This works really good, and it's really fast. And I especially like it that you call the function directly without doing any HTTP or something, which makes it really fast compared to doing this in like Python or Ruby. You'll spin up HTTP servers, which aren't great. Using Cucumber, you have the same benefit, by the way. We don't spin up a HTTP server. what I really don't like about this is a lot of setup every time. And yes, you can make helper functions, but those helper functions also make a little bit of magic, hide away some stuff, and like they are not flexible enough. That's my disadvantage. Yes, the same thing you could do is this. This is a way more complex example in Cucumber where I set up some teams in the database and some users in the database. Then when I get teams 1, the users, I get those two users and I can verify without running this. I expected team 1, that's Kate and Jane. I don't expect John, he's in team 2. Yeah, that looks good. Who here works with front-enders? Okay, imagine giving him this, my previous example, just a Golang test, or this example. Which one do you reckon is easier to read for somebody that doesn't do Golang, even though it's very easy to read? The Go one, nice one. I disagree. I think that's one of my main pros for this is this is just documentation. This is my test I write when developing, and I also give this to my front-enders. I often see like tabs open in their browser with GitHub links to my feature tests, because they use this to write their code, basically. And then that's my contract with them, and I promise to them my code will never fail, because I test it every time. That's a lie. Now, one of the disadvantages of the Cucumber is that once in your project, for example, given these team records, you have to implement the step definition. Although nowadays I'll copy them from another project, but this is an abbreviated example of the given these records in the database example. You'll get a table name, because I say given these teams records. It's the table name, and then below it I'll have a table with teams. So you get a table name and the table. I begin a database transaction, whether you use in-memory SQLite or something. I really like using actual MySQL or Postgres to test, because then you also test the quirks of your database every time you change something. And then I loop through the rows and insert the database. But you have to do this once. And that, if you're writing your code like this, you either have like a mock memory store when you call the function. It's a little bit easier. I agree with that. But then making new feature tests, it's super easy to read. I even get feature tests written by my front-enders. Like, hey, I really want it this way. Like, please, transpose the result of this endpoint. That's way easier for me to use. He'll copy-paste me mostly incorrect feature tests that I fix a little, but it's fine. Like, I know what he wants. It's a way of communication. Yes, the whys. The pros. The first one I've already said 6 times. Like, everybody can read these tests. I sometimes send them to my product manager. Like, are these the steps you expect or something? Is this calculation correct? Especially with finance things and applying VAT or something. We also describe them in feature test, and we can, I don't think we have, like, send them to our finance team, like, is this correct? Which is super nice. And in the beginning, I underestimated the strength of your documentation being your tests. Because if it's not tested, I also don't support it as an engineer. So you shouldn't have used that endpoint because there was no documentation of it, quote test. So I am very confident changing. In fact, your test coverage of your documentation is 100%. Even so that if I make changes to our API, I haven't ran our API on my laptop since the beginning. I just change my feature test, what I want. Maybe I ship that first to my front ender. Is this what you expect? Yes, okay. Then I'll implement the actual change. CI will run the entire suite and will ship it directly to production. I don't run it locally, open my browser to test if it's still working. Even the feature I'm working on, I don't test in the browser, which makes my development super fast. And I already mentioned Cucumber. You can like take all my search features from our backend, destroy them out of it, put them in my new service, which may be built in Rust because some search algorithm library in Rust is super fancy. And I can just use the same feature tests. When that's green, I can swap out in Kubernetes the endpoints, and my front-enders won't even know the service has been rewritten. And I'm very confident the rewrite is done correctly, because again, I have 100% test coverage of my documented features. Yeah, and the second one I also told is, after some boilerplate, it's super easy to set up new endpoints and new, also regression tests. Whenever, like, if you enter a name with a number in there, it breaks. I'll make a feature test that enters a name with a number in there. It will be red if I run it, and then, let me fix it. Regression test is super nice.
I have a question.
Yeah.
When you say 100% test coverage, it sounds like you shouldn't have any bugs. Or you have a lot of undocumented features, maybe?
Yes, I have a lot of undocumented features. Yeah, because we don't write every possible code path in Cucumber features. I still use also unit tests for functions to check edge cases. Yeah, doing maybe some fuzz testing nowadays. I won't test like entering an empty name or something in feature tests. Sometimes I do, especially if like a regression bug. I'll leave it in there as well. But it's too much overhead. It's too much files if you test all your edge cases in Cucumber tests. So I test the happy paths, the happy paths, and maybe some clear edge cases that are used often. Maybe one error, so that my front-enders know how an error response of a certain feature looks like, etc. But then the edge cases I use often unit tests, and then that's definitely not 100%. But yes, if you're using the same values as in my tests, then it will never break. So, problem with the user's name. I can think of two cons. One, it's upfront work writing these step definitions. I reuse a lot of them for HTTP calls, like this header has been set. I want to make that into a package, make that open source so it's easily used for other people, but I haven't been there yet. So. But I copy them now over from project to project. And one other con is it's a little bit slower than your unit tests. It needs to compile, then parse the Cucumber files, and then do regular expressions between the steps, etc. And then it runs the Cucumber scenarios. It's definitely slower than if you write it in your, if you write out all these tests in like classic Go tests. But I usually only run the files I change, which is like a second, and then CI checks the rest. In our test suite is 3 minutes now for okay-ish size API. Could be faster, but yeah. Maybe in the future the Golang runner will be faster, we'll see. Okay. The dreaded moment of the demo. I hope the gods will be happy. I have a little project. Can we read this from the back? Yes? Cool. It's a project which allows users to upload Flash files, and Flash files only to S3. Textbook service, it has one, like, it connects to S3, and it has one endpoint. Super small thing. I can actually show you the feature files, the scenarios. For good measure, I've also tested the health endpoint, this is from my slide, and the 404 to document an error. I have some more errors separately, and this is the actual feature. If the client uploads this SWF file, as Flash developers would say, to the /upload endpoint with these form values, a requirement was that you check box, this is my file, and that we record that. Was not my idea. Then the client expects a 201 created, and this should be the response body, where it has uploaded to some location, and it also gives an embed URL, which the client can then use to render to people. But then I not only expect this response, I also expect the fixture, the same fixture, to be stored at this location and gzip compressed, and that the headers of these files are these headers. It should have context plain, even though that's the incorrect content type, but then Cloudflare will compress it even further. And the encoding gzip, and we also wanted to remember the original file name, so it's an extra header on S3. And the claim ownership, yes, has been forwarded as well for somewhat legal reasons. And here's the scenario where you upload the same file again. So there's a given step now, given this object already exists. When the client uploads it again, it will get the same response. The client won't realize it's the same file, but no new objects should be stored. Could we make a front end for this now? I think so, right? We're not front enders, so it won't be pretty, but we can make a functional one for it. And indeed, I can just ship this to the front ender who was working with this. It worked pretty well, actually. One thing I did here, which I'm not sure about yet, in the actual code, it uses an MD5 hash of the file as code. But I found that to be very long in these scenario files and a little bit cluttered. So I chose that if test, use crc32, that is a shorter hash function, to make this more readable. I'm not sure if that was the right decision, because yes, it reads a little easier, but on the other hand, it's not what's actually happening in the real world, so it might be unexpected. The front ender might use a hard length array for it, I don't know. But up to you to judge if that was the correct goal or not. Yes. Okay. And one error, upload an invalid type. If you upload not a SWF file, but an image file, it will say a bad request, invalid type, and no object should be stored. Yeah, maybe my product manager says, we need an extra feature. You also users need to be able to enter their name, and it should also be stored somewhere. It's not a weird request, right, from a product manager. So what I'll then do is I'll just change my scenario, or maybe I'll even copy it and make a new one. Do repeat yourself in scenario files. Attach name to an upload. And we'll say author uploader name. We're not sure if it's the author. Thank you, Copilot, John Doe. Let's do a prepend space as well, just to make sure to do some. I expect the same things. I only expect an extra header on the S3 object, uploader name to be John Doe. Now, if this wasn't such a small change, if it was a bigger change with a lot more complexity, I could now already make a pull request, mark it draft, add a description, and send it to my front ender. Is this a format you can work with? Is this what we expect? Maybe I check in with my product manager. Is it enough information? Is this correct? And we can talk about it. This saved us a lot of time where I made this, and my front ender said, oh, I had a completely different imagination of this feature altogether. And we spent some time more in refinement, and we came to, and like, I was so happy I didn't start implementing this big feature, because it was a lot of programming work, and I would have coded something completely useless for us. In this case, we'll definitely won't make a pull request right now, because it's super small, we'll done in a minute, and if it's wrong, it's fine. I'll just close the pull request. Okay. Let's see. Go test, and then only the feature files. I have an error. I also haven't implemented the feature yet, so it expects the uploader name to contain John Doe, but it got empty string instead. I expect this, because I haven't implemented that it copied over this value. This is, by the way, how it looks if it runs. It just prints out the scenarios green or red if it fails or not, and then it shows diffs. If I want to commit it and I don't like redness, I can mark it as work in progress, which is something, just a tag. You can put tags on them, and I decide what tags do, and I've decided that I exclude whip tags. If I run it now, you won't see this new one. It will be 100% okay. But I'm developing. I want it to fail. So I can start coding. Luckily, I know the project. I also practiced this morning, so completely fair. Here I did the hash function is MD5 new. If test is envis test or local, use the CRC version. I'm still not sure if it's correct. MD5, I've had this exact discussion with Eric, is fine if you want to see if the files are the same. It's cryptographically horrible, but for files, it's fine. We'll have this discussion on Discord later. I'm going to do it very easy. I said X uploader name is, what was it, our form value uploader name. That's it. Let's have it run. It fails. What? I'm kidding, I forgot the space. Trim space around it. It's green. One of my biggest changes ever. Of course, it was a small change, but it was also super small. And I haven't done curl requests or anything, or alt up to my browser to upload a new file with a name attached to it, and I had to change the front end to include a name. I'm also fairly confident that I didn't accidentally broke something. If I would break something by accident by adding a space here, this is a bad example because I don't think I've tested this. If I somehow remove this one. So again, it's your own responsibility to test everything. Like in unit tests, you can also not check stuff. In this case, I then decided not to check the public read one. But now it fails my entire app. I make a pull request, Eric checks it, he thinks it looks good, we merge it to production. This is how we work for our developer platform. Cool. My demo worked. It's always good. I think those were my slides. I have some closing notes, but we already talked about it because of your question. And I find it super useful for regression tests as well. If I have a bug on the system, I get report. I first try to make a cucumber scenario that reproduces it, or even I get the cucumber scenario that reproduces it, and then I can very confidently fix the issue and ship the new code. Thank you. I think that's it for me. Are there any questions? Let's start from the left. Yeah, we'll pass. If we go left to right, we can pass along the mic.
I have two questions. First one is there some sort of standard library for Cucumber? Because my fear is you, inside your team, creating a domain-specific language, which is not transferable to different teams. It's great for you as a founder, but you cannot put it into CV. Second question is, by the way, your slides are beautiful.
Thank you.
Second question is it true that you test your Cucumber steps with Go tests?
Yes.
No, I'm saying like proper standard library tests. You use them to test your Cucumber steps?
No.
Okay, just curious
Yeah,
how deep
you
you
could.
went into that rabbit hole.
Okay, I'm going to ask two questions. Keep it for the next person a bit. So yes, these steps I defined, how they look, how I decided this looks, is something we decided. And an example, within Blendle, this was a company thing, and we had like a private Ruby package that did all the step definitions for all our projects. And there are some common steps for Ruby. I haven't found them yet for Golang. I actually want to make them for HTTP steps. And there's no default way to do it. There are some ways you should always say when this does this, and I really don't pay attention to those. Just do whatever we want. So I need to read up if I'm going to make an open source thing, but yes. If I were to make an open source library for HTTP steps, I would definitely unit test the step definitions. Like run the step definitions in a test suite when changing step definitions, for sure. We don't do it in our own projects because it's a lot of work. And you're already, so if you make a unit test for your sort function, do you test the unit test? No, that's my check to test if, like, I look at this is what I expect, so that's how I test my step definitions, basically. But you could.
You can also check regression of your steps with some sort of golden files or golden server.
Yeah, for sure.
Is known to work. Okay.
Cool. Okay. Next question. I think you had a question. Oh, you already have the microphone.
So my question would be that you mentioned that for Happy Path you use Cucumber, and for edge cases you use unit tests in Go.
Yeah.
Do you have a way to calculate the code coverage from both, or you use code coverage per test type?
I haven't. I think yes, because if I run go test, oh, wrong screen. If I run go test, it also runs the unit tests now. Hold on. I don't think this has any unit tests. Maybe it does. Nope. I think it does, because what I do is I use Go test main to run the suite. So I'm not sure if Golang then also records coverage. If yes, then yes. If no, then no. Okay, cool. What other questions do you have? Yes, sir.
Hi. Yeah, I was just wondering the definitions that match with the regex.
Yeah.
Are there sanity tests that you won't end up with a condition that it will match multiples of them and it will run the incorrect one?
Then your test will fail and you'll figure it out. If you write a new, I can show you real quick. If you write a new definition, because you made a test, then all is good, 6, and you run this, it will say, hey, I don't know this step definition, use this code, and it has a little regular expression in there for you.
Okay. But if on the other side, if there's 2 that match it?
It will give an error, I think. I haven't run into that yet.
Yeah, it'll know, yeah, okay.
Yeah, it's also up to you to make sure that doesn't happen, for sure.
Thank you.
You're right, could be an issue. Anyone else? Raise up your hand. Yeah, there in the back.
Can you take a look at what the steps look like for the HTTPs, or is it private?
No, for sure. Steps, HTTP. What I do, I have a little struct which has the handler and a request and recorder. And before the scenario starts, I initialize them with an empty one. And then the step definition, when the client does a request, it will set the request and a new recorder. And it then recovers the abort handler. And then it does the serve. And then the step and the status code should equal. Will then give an error if the recorder was nil, because then I just misused my steps in the wrong order. If the recorder code isn't status, I read the entire body, and I'll return an error. The code is not the expected code, and this is a snippet of the body. And this is a minimal one. I think the steps we use for our actual big backend is a little bit more complex, where the JSON compares, for example, uses a complexer diff. So you can see I'm missing these keys in your diff. Yes.
And that dog library?
GoDoc, yes.
With DSL, it has like, apart from the table, does it have plenty of other?
It has a couple of others. I only see the basic types and the table. I'm using an old version here. Yeah. And I usually have a util function to convert such a table to like a key map value or something. Yeah. Cool. What other questions do you have? Sir, yes.
I recently tried to use the GoDoc library. I used Cucumber before with JavaScript, but I was using rules.
Yes.
But I think this library doesn't support it, or I couldn't find it.
Rules.
Like.
I don't think I've used those before.
Okay. Okay.
Okay.
This is the question.
I'm going to Google this tomorrow, so I can't answer that for you, sorry. Any more? Yes, pass it along.
Yes, I have a question. So I saw that you added the background section to one of the features. And is that like a feature of Cucumber that you can extend it, or is it your...
Nope.
Okay.
I don't have it here, sorry, I have it in my slides. There. No, that's just default Cucumber. I don't have code.
Oh, okay. Yeah.
It also works in Ruby and in everything. That's part of the spec of Cucumber.
Yeah, I have another question.
Yes.
So, it's nice to have your code in or your test cases in a programming language. So you can also you're also able to refactor it, right? So, yeah, refactoring. Yeah, I don't suppose that's possible. How's IDE support for this? Suppose you rename a step, for example. You change the...
There is IDE support. You saw me format the table in Cucumber with one keystroke. That's something you're going to find a fix for, because it happens a lot. There's even autocompletion for Ruby, I believe. I haven't looked for it for Go. It just autocompletes, and then you get like fields to fill in the values. I've done some regular expression search and replace, works fine, because it's very easy. They're all line-based. There's no like brackets, multi-line things almost. I often rename steps, and then I just rename the regular expression, I do a search and replace, and it works fine. I'm sure there is IDE support for it.
Right, yeah. I have one question, if I may.
Sure.
If you're working in suppose you're working in a huge team and you define all these steps and everybody defines his own steps.
Yeah.
Is there a way to generate documentation for your steps, or?
So then definitely you want some autocompletion. And I would definitely do like a process rule that when step definitions are added, some extra code reviews are required from seniors from other teams as well. So some senior from another team say, we already had the steps, but the order of the sentence was different or something.
Right.
Yeah, because if you make a typo, it thinks, hey, this is a new step definitions. Most of my step definitions can be singular and plural, given these two things exist, given this one thing exists.
And you express that in the regular expression?
The expression just has things, question mark.
Yeah, right. Okay, thanks.
Yes. Cool. What other questions do you have?
No more questions.
No
Then
more
let's have a
questions.
break. Thank you, Koen.
Thank you all for listening.
Let's have a break until 8 for half an hour, and then we have either 2 or 3 more presentations. So
we'll see.
We'll see.
girls in Miami.
وقد فنيت روحي عليك صبابة، فما أنت يا روح العزيزة صار.
Test. Okay, everyone, please sit down. We're gonna continue with our talks. We still have 3 talks to go to, so hope everyone is okay with being home late. We'll lock the doors. Everyone needs to be here until 12, and then we'll open the doors again and you can go home. So, okay, the next talk is by a speaker that's actually on holiday here. So he was like, okay, I can do a talk. I'm here anyways. So everyone, applause for Hatan.
Hello, everyone. Ooh, that's loud. Hi, folks. As you just said, I am here on vacation, holiday. My wife was very kind enough to let me do this talk. I said, hey, I want to go to a Go meetup. The look on her face was like, really? I need a nice dinner for that. I said, no problem. So I'm going to make this quick. Well, we just went to go eat, so she's good. I wanted to talk to you about a tool that, well, I guess first I should introduce myself. My name is Hatan Shobukchi. I'm based out of Los Angeles, California. I am a software engineer. I work alongside customers and some of our product teams at Microsoft. So we've been working on some pretty interesting stuff, and I thought I would share one of the things that we've been working on, which is the Azure Dev CLI. It's a brand new CLI built in Go. I'm not going to spend a lot of time diving into it. I'll just do a little bit of an actual introduction, and then I'd like to maybe talk about some of the actual decisions we had as we built the actual CLI. And me and one of my coworkers specifically, we basically added 2 new features recently. One is we added support for Terraform. The other was, and we're actually working on it right now, is basically adding support for Azure DevOps. So I'm going to show you a little bit of a sneak peek. So with that said, let me just kind of walk you through what this is. So, and it might be actually easier to just go and just jump right into here. So we have an actual CLI for Azure called AZ. So you can invoke things like you can do AZ group list and -o, and then you could get output in either JSON or, as here, in tabular format. If this works, hopefully I'm on Wi-Fi, yes. So this is a really good tool, and there's a lot you can do there. Basically, any resource you've got, whether it's a VM, storage account, you can basically use this entire tool to basically deploy infrastructure if you want to. In fact, one of the things I share with people as they go on their journey towards Azure is don't go through the UI. Like, kind of force yourself to go down this route, and it's a great way to really get comfortable with the CLI tool. But with that said, this is a very cloud-intensive tool, meaning you need to really understand how does this work. I need this resource, I need that. And it's not really developer-friendly for folks that are new to the entire cloud ecosystem. So with that said, we did build a tool, and it is out right now as an actual preview called the Azure Developer CLI. This is an actual tool where you can very quickly bootstrap infrastructure and also deploy an application. So kind of think of it as people have existing templates. You can say, I would like to use this, and I'd like to basically bootstrap a version of that particular template. We have some that we ship out of the box, but you can also build your own if you want to. So let me show you how this works. And actually, I'm just going to make a new one because I was doing this before. So how's the font size? Maybe I should make it a little bit bigger. Is that better? Okay. So the way this works is we have an actual CLI tool called AZD. This is written in Go. you can do something like azd templates list. So, or azd temp, excuse me, clear, sorry, azd templates list, no command, template, sorry. As you can see, this is very rough. So here are all of the actual templates we ship out of the box. These are all kind of example getting started apps, but you can basically build your own, and the idea is for people to kind of eventually build their own templates, either as open source, or they could build them for their internal company. So with that said, let me clear out of here and let's do azd init, and I'm going to do dash dash template, and then I just know that one of the actual ones we've got is to do Python Mongo. Now this is the name of a GitHub repo. What I can do if I want is I can basically specify an actual org. So I can say, like, you know, this is my GitHub username. So you can, in theory, pull down any template as long as it's in GitHub. But in this case, I'm just going to run this. You'll see that it did say, okay, we're going to go and we're going to configure this. You do need to give this an actual environment name. So I'm going to say demo2 just because. And then there's a few Azure-y things, like I have to pick the location, and if I've got multiple Azure subscriptions, I'm just going to pick mine. What I can do now basically is do azd up. This will deploy the actual infrastructure and the apps itself. Once I'm done, I can do azd down, and it'll basically tear down the app and the actual infra. What's really cool though is I can also do this, azd pipeline config. Now when I run this, the actual default is GitHub, and it'll do a few things. It'll first check to see if the application is a Git repo. If it's not, it'll say, okay, let's go ahead and let's actually add one. Then it'll say, would you like to basically create a new Git repo, use an existing one, or so forth. If you do elect to basically create a new GitHub repo, we basically make a call, create a new GitHub repo, configure GitHub actions so that you have a full CI/CD pipeline, which is really, really cool. So one of the new features that we just added recently is that you can also do this now. You could essentially specify Azure DevOps as an actual CI/CD tool. If you have not used it, Azure DevOps is one of our other orchestrators in addition to GitHub Actions. So if we basically run this, I can say yep, and then I could basically create a new Azure DevOps project. I'm gonna call this Go Meetup 2, why not? And then at this point, it is going to basically configure an actual project for me, and it is going to bootstrap the entire CI/CD pipeline so that I can essentially deploy the app. It's really built for the kind of newish developer who just wants to deploy cloud infrastructure, but may not yet have a full understanding of what are all the different things there, so that you can essentially package this up as an actual tool for them. You'll see here I've got a link, and if I go to this link, you'll see that we've got a new repo here. We've got a new CI/CD pipeline, and we've actually invoked the pipeline as well. There's a few other things we do set up for you. We set up service connections for your secrets, and we also set up a build policy so that you build on an actual PR. So that's that. But you know, I just wanted to show what the actual app looked like, and the app looks like this, and there's a bunch you can do there. And the thing that we also do is we also deploy an actual And we also deploy an actual dashboard. So I can go to the actual dashboard, and what I really like is just with that AZD up, you get the actual app, you get the underlying infrastructure, and you get a really nice dashboard as well so that you can watch the app. But let's go look at the actual Go code itself. So this is an actual Go app. This is written, it's a CLI tool, so this is using Cobra, which if you have not used it is a great CLI tool for basically parsing input. It's got a really nice structure. The thing I just showed you right now was the actual pipeline config action. So that is this particular pipeline command. And what we've done under the hood is we've basically built an abstraction called a pipeline manager. This is how we can essentially have this top-level abstraction that would essentially invoke different providers. So if you'd like to do one for GitHub, Asdo, and whatnot, and we've got an actual method we wrote to kind of dynamically figure out what you want based on the actual input, and we can inject it in. So that was really cool. One thing I thought I would show also is if you are using VS Code, this is a really cool feature that I just learned about recently, which is while you can easily debug Go from within VS Code, if you just add this line here, console integrated terminal, this changes the debugging experience just a little bit, whereas it won't actually output debug logs to the debug console. It'll use the built-in terminal. This is really useful for situations where you might want to debug, but you require human intervention. If you're using the debug console, human intervention is very hard, and you basically can't gather inputs, and you have to basically mock that. Here, it just becomes very easy to basically run this in the actual terminal. Select what you want, and you'll see here I do have an actual input. I'm going to say yes, yes, and now this should actually break right here, hopefully. Let's see. If not, the demo gods are not with me, and I will move on because I'm almost out of time. Let's just move on. Demo gods are not with me today. Thanks, guys. Okay, with that said, one thing I did want to show as well is we do rely on a lot of underlying tools, Docker, Terraform, and a few other things. And one of the choices we made early on was, do we call native APIs, or do we just wrap the actual CLI tool? What we began with was, well, let's just wrap the actual tool, and let's build kind of an exec package where you can basically shell out. That worked well. But at a certain point, the actual list of dependencies that we need got a little large. So now we're kind of looking to say, should we refactor and should we build this with actual APIs instead? At first, the actual choice was, let's just go with the underlying tool. We don't have to worry about linking in other libraries. We can just basically shell out. And we built a really nice abstraction so that it looks pretty seamless. So if we were to look at the actual infrastructure provider, and let's say I looked at specifically the actual Terraform provider, we can do things like CLI plan, CLI apply, and so forth. When we built the actual Asdo implementation, Azure DevOps, we took a slightly different approach there. There, we kind of decided to go with the actual Azure DevOps API and not to use an actual CLI tool. this way we can essentially keep things small in terms of size, and to be quite honest, it was a lot easier to unit test compared to needing to shell out. So yeah, I think I'm at just a little bit over time, but just wanted to share a little bit about the Azure Dev CLI. If this is something you find interesting, if you just search for Azure Dev CLI on Google, I mean Bing. I use Google myself. And yeah, it's the first link there, and I'd love to hear feedback, thoughts on this. It's just a way to say, here's an application, here's all of the actual infra, and yeah, we're going to add a bunch more features, and it's all in Go, so we're very happy with that. Thank you, everyone.
Questions, and
Questions.
I'll
Oops,
ask
sorry.
the first one.
Sure. I'll plug this
How
back in.
difficult was it to convince your manager to use Go, a Google language?
That's a good question. So I am lucky enough that I am technically, and I should have said this before, not part of the Azure Dev CLI team. I'm basically part of a team that we work with a bunch of open source tools and whatnot. So when people need specific features, need things, they're like, hey, do you have the resources and also bandwidth to kind of help out? And I just so happened to have time right before vacation to basically work on this. So I joined them after they made the choice to use Go. With that said, we use a variety of different languages. Under the hood, the AZ CLI, the main CLI is written in Python. We've contributed to TF-lint and a bunch of other things, Terraform, TerraTest. So we actually use Go quite a bit, and we're very big fans of it within Microsoft. So, okay. Any other questions? Yes.
Hello, hello.
Hi.
Question,
Sure.
does the tool generate Terraform files in the end? Or?
So the tool doesn't generate files per se. The tool uses existing templates to kind of bootstrap an app and deploy an actual app. So you have the choice as an actual template author, and I'll show you one. I have one over here. So like this is an example. You have the actual choice when you define infrastructure. You can either have bicep files, or, and we just released this like last week, you can actually deploy Terraform now. So you have the actual choice, and I should say that there is a file called azure.yaml, and this is kind of an actual metadata file that the actual tool uses to kind of infer what are the things that I should run. And if you see on line 7, this is how we basically instruct the tool to use Terraform. Yeah, and we're looking at seeing if we can add testing support soon too, so that after you deploy the actual infrastructure, if you do have TerraTest, you can maybe run that. So, yeah.
Thank you.
Sure. Any other questions?
Very quick question. Is
Sure.
the AZD tool open source?
Yes.
Cool.
It is completely open source. You can go look at my PR and see all of the errors I have. No, I'm kidding.
Nice. Cool.
Any other questions, concerns?
Silly question, but it's
This is
possible
a-
to script against it with all the prompts that you get, and you can just...
It is possible to script the prompt. So it depends. We do have integration tests where we essentially pass in defaults. So there is a mock console object that we built where you can essentially say, for the first one, just type this in. Pick the first option, do this. So we do have that as well. I just myself wanted to go through the actual manual bits, but you can do that. I just find it easier to test multiple workflows, because on some of our kind of menus, they kind of nest fairly deep, like you pick this and now you have to pick this or this, and then you pick this, and then I want to be able to go back and forth and test quickly. So we do have tests that are all scripted out with the default options. As I'm writing the code myself, I feel like, or the little bit that I worked on, I feel like it's a little bit easier to just use the actual console so that I can say, okay, now I want to try this particular code path. Now I'd like to try this. But yeah, there's a mock console object, there's a mock console package, and it basically does what you asked.
Thank you.
Very long answer, but thank you for the question. Any other thoughts, questions?
Last one.
Okay.
Thank you. Cool tool.
Thank you.
A lot of CLIs in Go, they assume that you're going to use CLI only to execute the internals. But sometimes I find myself not able, like I want to build on top of this code. So do you provide like public functions that I can like extend and you like launch the same from within Go program without shelling out?
Kind of. So not for the core tool itself, but a lot of the actual packages we built, like I said before, we kind of wrap underlying tools, like we wrap Git, we wrap Docker, we wrap a few other tools that you can invoke. Those are currently exposed as libraries you can call alongside the Azure DevOps API. But as far as the core tool itself, as far as I know, that's not something that you can use in a different application. But that's a really good piece of feedback that I'll take to the team. And I will use my get out of jail card, which is this is still in preview, but that's really good feedback that I will take back to the team this week.
Thank you.
Thank you. All right. Thank you, everyone.
Okay, thank you. Our next speaker will be Ilya, talking about concurrency patterns in Go. Okay, while he's setting up, I'm wondering, how many people here use Azure? 4, okay. How many people use Google Cloud? Also not so many. Is everyone else on Amazon or? Okay. Oh, wow. Okay, okay. Interesting. Yeah, who runs their own hardware? Oh, also a couple. Okay. Yeah, interesting. Okay. Okay, I'll come up with questions. Who already wrote some generic Go codes? Let's see. Less than half, like only a couple of people. Everyone upgraded to 1.19. Or someone still not on 1.19. Not. Shame, shame, shame. Okay, Ilya, take it away.
Hello? Yeah. Okay. Hi. Hello. So I'm Ilya. So I've been thinking a while. I've been wanting to give a Go talk, and I couldn't really figure out what I wanted to talk about. So, like 4 months ago, ex-employer that I wrote something in Go 11 years ago contacted me. It was compiled one of those early R versions. I think it was 6 something. Not exactly what is happening. Oh. Okay, so was looking at the code and I was thinking like, what was I thinking writing like that concurrency in Go? So I decided to let's create a refresher, and everyone probably could benefit from it. So concurrency by definition, is the ability to break down a computer program or algorithm into individual parts, which can be executed independently. Well, the final outcome of the program is the same as that of a program which has been executed sequentially. Using concurrency, we are able to achieve the same results in lesser time, thus increasing overall performance and efficiency of our programs. The trick with writing concurrent programs is to ensure correctness of your program yourself. Therefore, keep in mind that all individual chunks of your concurrent program should be executed independently and have access to the shared memory. Yeah, they can read and write to and from the same memory location. All you actually need to take care of is the allocation of resources so that no process starves due to those lack of resources. And in addition, you will also have to synchronize and coordinate between processes so that you can prevent deadlock if they're dependent on each other. So in short, yeah, parallelism is the simultaneous execution of multiple things, possibly related, possibly not. Concurrency is doing dealing with a lot of things at once. Parallelism is doing a lot of things at once. It's a subtle difference, but the difference is there. There is a very good talk by Rob Pike. Concurrency is not parallelism, so if people are interested in it, then I do recommend they give it a read. It's about 30 minutes, I think. So before we actually start talking, we need to start talking about some building blocks of concurrency. So the building blocks of concurrency in Go are the Go routines, helped by, we have channels, buffer channel, select statement, wait groups, mutexes. There's a very nifty package in Go, sync package, and also runtime package that actually helps with all that stuff. So let's look at them individually. Go routines. I don't know if you guys are aware, but the Go routine works on something called the fork join model. So the fork join model essentially implies that the child thread processes split from its parent thread process to run concurrently with the parent process. So after completion of its execution, the child process merges back into the parent process, and the point where it joins back is called a join point. Go routines actually work in a similar fashion. Sometimes you won't have a join point in your program, for example, in case where the Go routines only print onto the console and exit. On the other hand, if you have a join point, then you have to synchronize your Go routine with the rest of the program. Essentially, Go routine doesn't mean we are necessarily running stuff in parallel. They can be run sequentially in the background, or they can start running at different times. On the other hand, parallelism really depends on the underlying processors and CPUs available. Therefore, Go routines can actually give the illusion of running in parallel while just executing concurrently. Go routines are lightweight threads, very lightweight threads that use a few kilobytes of memory, and they actually use their own. So all the Go routines actually have their own. Actually have the same address space. So it's our job to actually make sure that we implement concurrency while keeping in mind the prevention of race condition and handling synchronization issues actually between concurrent operation. And also they have their own code stack that grows and shrinks dynamically. So first thing, let's look at channels. Though I think everyone is aware of channels. Okay, I see people nodding. So yeah, so for a concurrent program, concurrent processes have to operate individually, but with a shared data stored. But like I said previously, this leads to problems such as race conditions. So there is channels are based on Very interesting read, and I would recommend for anyone that's interested into data, computer science, to read a paper on communicating sequential processes by Juarez that was written in 1978, so long even before my time. The QR code points to the actual publication if someone wants to read it. So Golang makes use of channels to achieve communication between concurrent processes. And there is a famous quote on the Golang page that says, do not communicate by sharing memory, share memory by communicating. Well, if faced literally, it can mean a lot of things. But I'm not going to go into now explaining what exactly do not communicate by share memory community means. So now, channels. Yeah, this is how you make channels. Very simple. Make channel of data type. So you have two types of channels, normal channels and buffer channels. Buffer channels are just channels with a capacity and a buffer, a capacity buffer. Very easy to create, very easy to send data, very easy to receive data, and very easy to close a channel. So closing a channel actually means that you can no longer communicate it. And when actually dealing with channels, it only makes that actually the sender and not the receiver closes the channel because the receiver usually doesn't know if it has received everything or not. So channels also here's a copy paste of the Go playground that actually showed the channel can also have directions, thus preventing of you accidentally sending or receiving something over a channel when you're not meant to. The next thing we're going to talk about is select. I think everyone has seen select. They're quite commonly used with channels to receive data. This is a simple example of how select actually looks like. So nothing complicated here. So actually, this was supposed to be before the later slide. Yeah, sorry, it's okay. So we have three types of selects that have a default case, a nil channel, and an empty select. Do people have ever worked with nil channels or empty selects? Yeah, good. So let's see a default case. Here is a default case. So what happens here? It executes. So the default case execute with whenever the other send receive operation is blocked, which means it's waiting for data. If we have more than one send or receive operation ready at the same time, Go just choose one and randomly. I don't know how they choose it at randomly, but it just says that it chooses it randomly. So, and let's see the nil channel. Nil channel is interesting to use because it blocks the select statement forever. So if you just have a select with a nil channel, you automatically get a deadlock. So, but another benefit of using a nil channel is you can temporarily disable send and receive operations in a select statement. And to avoid a deadlock, we actually have to have at least one operational channel in the select or a default. Just running a default constantly is not a good idea because you're actually for a select, unless you pair it with a for, you probably won't have that. But we'll talk about that on the next one, I think. Here, this one. So, empty select. Well, running this one gives you a deadlock. Well, makes sense because the main is the only routine that actually runs. But the empty selects are actually quite useful for blocking execution of the current Go routine. How many people have used for with a bracket with a time sleep to prevent max CPU? An alternative to that would actually to use a select statement, which would block the go routine and actually put it in a sleeping state. So the package sync. The package sync actually has some very nice tools that we can use to help us deal with concurrency. They are con, mutex, once, pool, read and writes, mutex, wait group, semaphore. Semaphore, I think it's still in the Golang X. So, sync. The QR code points to a link where you can see the Go code executing in the next slide. So, sync con is actually effectively very simple. It implements a condition variable which indicates the Go routines which are waiting for an event or want to announce an event. The thing to note, if you actually call con wait before con broadcast, well, the Go routines, the listeners would actually keep on waiting forever. So here is an example of how you would use actually sync con. So we can create, if we want, 10 listeners. So when we actually run the application, all the listeners, in this case we have 2 listeners, will actually output the value that we have in A. In this case, all of them will output 25 at the same time. So this can be very useful if you want to broadcast same information to multiple, to multiple people, to multiple listeners. Sync.
Why are we using that within logs? Do we need to use the condition?
Yes, because sync on actually do extend from lock, so you do actually have to lock and unlock when you need to use it. The time sleep there is to make sure that the broadcast is actually not called before wait, the con wait. So I'm kind of cheating a bit. That's all? Okay. Yeah, okay. Next one, mutexes. I think everyone has used mutexes. So mutex, or a mutual execution, which prevents other processes from entering a critical section of data while the process is occupied. They are quite useful for making sure that you read or write to a non-thread safe data. And a subset of the read-write mutex is also something called a read-write mutex, and that one is actually optimized for multiple reads and a single write. So multiple consumers can read the correct value, while only one writer can write to it. Sync once. So this is just a simple directive that allows you to perform an action once and only once. Running this code, well, one's body will only execute once. If you actually run this, even though it creates 10 Go functions, it will actually only output only once. So this can be useful if you want to close channels when the application finishes, because I don't know how many times I've ran into a channel has been closed before. Sync pool. So sync pool, I was thinking to write some kind of code with it, but any code I kind of came up with it was a bit too long, so I kind of just decided to write some text about it. So sync pool, I think everyone knows that it's just a collection of temporary objects that can be accessed and saved by many Go routines simultaneously. So, and one thing to note about the sync pool, that it can automatically, any item stored in the sync pool can be automatically removed. So the pool actually only holds just a reference to the item in question. So when that happens, the item is just deallocated. And the reason why you would use pool is because they're actually thread safe, so you can actually use it across many Go routines simultaneously. So a very good example of the sync pool is the actually Go FMTP package. If you actually open the source code, there you can see quite extensive use of the sync pool package to actually achieve writing continuously to the console. Wait group. Wait groups are also quite simple. It just blocks the program from finishing while it waits for a set of Go routines to finish before moving on to the next steps of execution. In this case, VG wait will block until both Go routines finish and then continues with execution. Sync semaphore. You can actually use them as a worker pool. Semaphore, this is from computer science school, but the semaphore was actually proposed long before my time by Dijkstra in '65, I think, which is a very significant technique to manage concurrent processes by using a simple integer value, which is known as a semaphore. So a semaphore usually is simply an integer value that is shared between the threads. So this variable is used to solve critical section problems and to achieve process synchronizations in a multiprocessor environment. So the semaphore are of two types. Binary semaphore, which is just a 0 or 1, so essentially a mutex, and a counting semaphore, which what we can use to implement a working pool. So it's a value that can range over an unrestricted domain, and it can be used to control access to a resource that has multiple instances. So if we look at a worker pool, we need to make sure that our worker pool only executes, let's say, n Go routines at a time. You would require a semaphore, and in each loop it would wait until another Go routine releases an item before you can continue. Implementation of actually a worker pool with sync semaphore is quite trivial, actually. And I think everyone is aware of this one. This is baked into the Go library. So the Go max pros allows us to set the maximum number of CPUs that can be executed simultaneously. And calling the function will actually return the previous value and set the new value. But if you call Go max pros with actually 0, or any number less than 0, it actually will return the previous setting you have set. In this case, it will call 3. No matter how many times we call it, we will get 3 as a result in this case. And the last one is the num CPU, which actually returns the logical CPUs that can be used by the current process. So that was just a small intro about the basics. So let's see about synchronization of values. I wrote some very simple benchmarks. So they're not real use case, but it will give you a very good idea of what you can use where performance is critical. And well, enough said, let's talk. So benchmarks, no synchronization. Here you go. Just a simple variable defined out of the function and just increase j. On a 4-core, it ran 870 times millions. On a 16-core, it ran 1 billion times. And it was like 0.2 nanoseconds per operation. So obviously, no synchronization is always the fastest. So let's see what happens when we use atomics. Still quite decent.
Was the result actually correct?
Yeah. The benchmarks are, actually, I don't know if I published the repo, but I'll make sure I published all the benchmarks are there. The benchmarks run over 10-second interval with a 5 count. So each bench run 5 times. So this was the average of all 5 operations per benchmark.
Does anything run concurrently here, or is it one Go routine that's doing all that?
In this case, it's just one. Using atomics. Atomics give, well, as you can see, about 183 million operations in 10 seconds and 737 on on 16 core in 10 seconds. Nanoseconds per operation is still quite acceptable. But now let's see the interesting parts. Mutexes. We have a significant drop. So now it costs us about 30 nanoseconds to run a mutex. And here we're still talking about a single thread. Yeah. And here's the channels. Using channel to actually update value, it's 30 million with 57. So quite a significant, I would say, decrease. So if you really need, so here are the results side by side. So if you really need performance when you have to, yes?
So if it's still single thread, is the same speed on the CPUs, or why is it faster on the 16 core?
Because you have 16 core. Oh. Actually, maybe it not be single. Well, the 16 core can actually run a lot more because Go actually abstracts.
Single thread.
Oh yes, did it? But I think they're running in single thread.
What kind of machines did you test it on? The 16 core faster, maybe?
Oh, you definitely on this one, and I have a 16 core AMD with. Yeah, it's a lot. It's clocked quite higher.
So it's not the core counted; it's the CPU speed.
Yes, it's the CPU speed. So this, in this case, may actually be a bit misleading. So properly would have been to add one core with the CPU, the clock speed. But okay, so here is why. Here is what happens. So when you actually run this one, so this doesn't really matter when we run it in a single thread or multiple thread. Here is a profile map of how the stuff is executed. So you see no sync and atomic have almost no underlying function calls. But if you actually see the mutexes, well, 16% of the time was spent in lock, 16th in unlock. But when you actually go to the channels, you can see there's a lot of stuff more hood. So it actually does make sense that this is happening. And now for the fun parts. Patterns in Go. By a long shot, this is not an extensive list. These are just some that I could think of at the top of my head. And we'll actually see some of them. So generator patterns. So generators usually return the next value in sequence each time they're called. And each value is available as output before the generator computes the next value. So here's an implementation on Fibonacci with a sequence, with a return channel, with a generator pattern. Some people would say this is an anti-pattern. Some people will say, but this is just an illustration of how you could actually use them to provide a generator pattern. For select, I think this is the most common one. The just select statement lets a go routine wait on multiple operation and blocks one of the cases that can run. We already talked that there is a random one, if both of them are ready at the same time, a random one is chosen. And if there is a default, it will execute on every loop without blocking the loop while waiting on a channel. So essentially running this, and there's nothing in the channels, you will actually kill your CPU. So in this case, a better option would be to actually add a ticker that ticks every certain period if you want to use this kind of implementation. Range and close, same application, Fibonacci with range and close. So only the sender should close the channel and never the receiver, and sending on a closed channel actually results in a panic. And closing is only necessary when the receiver must be told that there are no more values coming, such as to terminate a range loop. In this case, we finished with the counting and the calculation of Fibonacci, and we close and we're done. Then the for cycle knows that it needs to terminate because it actually waits on the for loop below where the range is set. timeout using select. There are cases where you actually want to cancel or return an operation. So you can use also timeouts using selects. So this is a very simple implementation of how you can terminate a select after a second. Quit channel. Running this will give usually different outputs every time. We use quit to determine when our application is actually complete and when it's actually finished and when we can run and when we need to stop. I think a lot of people probably have seen and used this kind of patterns. And I don't know if people have heard or seen this channel ring buffer. Usually this is used, you connect two buffered channels that forward messages from the incoming onto the outgoing. So if a message cannot be placed actually in the outgoing, it actually discards the oldest message in the outgoing. And the downside of this is that slow consumer might lose messages, in this case the ordered messages, but it will never block. And implementation is actually relatively simple. Everything that we talked about before, just with multiple channel. So this one always discards the oldest elements. And fan in and fan out. I was also looking into a way to create a code for this, but everything that I came up was a bit too big to fit onto a slide. So I think most people are aware of the fan in, fan out model. It's a way to converge and diverge data into a single data stream from multiple stream or from one stream to multiple stream or pipelines. So for in usually refers to a technique in which you join data from multiple inputs into a single entity, and fan out, you divide the data from a single source into multiple smaller chunks. And I think that's it. Thank you. Any questions?
One question. At the very start, you mentioned that the Go routines have a very low memory footprint.
Yeah.
For me, the Go is the lowest level that I was ever doing serious work in. Do you know, or maybe anyone else, how that compares to other low-level languages? I heard someone complain about it once, like, oh, actually those few kilobytes can be a lot, but I don't know how what to compare it with.
Well, if you compare it to mainstream languages like C and Java, the difference is huge. 2 kilobytes are actually peanuts in comparison. I don't remember, don't quote me on the numbers, but I think there's like, in Java it was like 2 megabytes per or more.
B threads could be 4 megabytes, 16 megabytes.
16 megabytes.
They cannot grow.
Yeah.
So, and some call stack may go really deep.
Yeah.
And if it's too short, then your program will crash. So it's really nice that it's just small, starts out small, but then grows as needed and also shrinks back.
As needed, yeah.
Thank you.
So that's the benefit of the Go routines.
I also have a question. You talked about sync.semaphore, but that's not a thing. At least not in the sync package. It's in
it's in the sync. It is, but it's in the X package.
Yeah. So the question is, why is that in the X package and not in the main package?
Actually, I have never really thought about why it's in the X package. It is a flawed technique. So the techniques that we have currently in the general package are a bit better. The reason why I added the sync package there is because it's very convenient and very easy to use, especially when you want to build something very easily.
Okay. Any other questions? Who has ever used sync.semaphore before?
Yeah.
Oh, at least some people. Okay.
Yeah.
Oh, yeah.
what I have not noticed is that people tend to overuse concurrency when they have this option. So what is your rule of thumb when to start using concurrency? How often you witness a situation when single threaded application outperforms concurrency?
Yeah, so actually that's a good question. So I had actually a code test about a year ago or something. The company asked me to actually write them a small example of processing data using a concurrent pattern and to actually choose which one is more performant. And so the reasons why I talked about the basic building patterns is that, and the benchmark is that actually gives me an idea of what I can use. In their case, they expected to see channels, but that wasn't clear. So I actually built it with semaphore, but when they said they actually expected channels, I wrote them a version of a channel with an explanation and a benchmark. The semaphore version outperformed the channel version by almost 15%. We're talking about ingesting about 40 gigabytes of data on my gaming machine, let's call it the 16 core, in about 5 seconds, while the channels took like 15. And I ran into a lot of issues with memory there. So how I would choose? It really does depend on the problem and what am I trying to solve. It's very important in Go where you keep your data. Do you keep it on your stack? Do you keep it on your heap? Does it actually make sense to pass values as reference or not? Copying a value in Go is very cheap. Pulling a value with a pointer is actually a lot more expensive. So you need to actually figure out, I don't remember exactly what was the cutoff point, but I think it was a couple of kilobytes. So if most of your data fits within that range, it's actually cheaper to copy the data into the function that actually pass it as a pointer. But that's...
Potentially if it fits into a cache line, which is 16K, right?
I don't understand.
So CPU cache line, then it is still efficient to pass it by value.
Yeah, in that case, yes. And most of the new CPUs have quite large caches.
Okay.
Can I add a simple rule?
Yeah.
Do what's ever easier to read for others, unless it becomes a problem.
Yeah. I completely agree. And make sure your solution actually solves the problem and not over-engineer the problem.
So the rule is, if you're a fresh programmer, a Go programmer, if you're a fresh Go programmer, then you use it a lot. And if you're a mature programmer, you just use it a bit less and more appropriately.
Yeah.
And I might add to that, if you need to do like 1,000 things, 1,000 pieces of work, you can write some really complicated like queue or whatever. Just start 1,000 Go routines and let the Go scheduler figure it out.
Yes,
it's always a lot easier.
Yes. You don't have to worry about it because lately the C groups actually control how many processes you can spawn. So worst case, you'll crash your user, not the system.
Any other questions? One more.
Hi. How do you approach writing tests for the code use Go routine?
Yes, so actually that really depends on what kind of pattern I'm using. Sync cond logs are actually quite useful when you actually wait on data from a concurrent test. I've used timers, which, yeah, I know, don't shoot me, but yeah, sometimes they pass, sometimes they didn't. So it's very, yeah, so it's very important to actually have your synchronization in order. So there are, you can use wait group, you can use sync cond, or other type of mechanisms.
Okay, let's go to the next talk.
Okay.
Thank you.
Thank you. Yes.
Most important rule when running your concurrent code or parallel code or testing it is using the race detector.
Yeah, this one doesn't tell you. It's the resolution.
Oh, okay.
It was at 4K.
Too much.
Yeah, too much.
You should have told me I would have lowered that.
But I capture from the camera. But if you have another laptop,
Eric, can you use yours?
Yeah, of course.
Usually there's too much swapping around, so I thought I'd just
Do you wanna?
use whatever was there. You know.
Yeah, I can lower the resolution if that helps you. Yeah. Yeah, that.
Technical problems. Apparently the laptop resolution was too high for the video we're recording. And Michiel is going to talk about reproducible builds, was it, right?
What was it, eh?
Yeah, you keep changing your topic.
There we go. Yeah, oh, well. The topic is, it's a tool I built called GoBuild. It builds Go code, just like you always do when you build your Go code, but of course it does a few extra things that make it a bit more interesting. And it is a web application, so it builds code that's available on the internet and gives you a binary in various forms. But yeah, I don't have slides, I just have the website, because it's public. Oh, yeah. All right. There we go. Reproducible Go binaries with the Go module proxy. So GoBuild is this website. This is being served by GoBuild. And it creates your binaries deterministically or reproducibly, meaning it will give you the exact same binary output, the same bytes, every time you build the same program. So if you give it the same input, it will make the same thing. You have to be a bit careful to get that, and the Go team is actually making the Go compiler, the toolchain, so that it can produce binaries like that. So the same every time, but you have to add some flags and you have to be careful. But GoBuild does a few extra things. Besides the deterministic thing, which is a major feature, it also stores the hash of that deterministic build in a transparency log. I'll get to that a bit later. What it can build is anything that's available in the Go module proxy. So who knows what the Go module proxy is? Yeah, okay, so still something to learn. Nice. So the Go module proxy, and links here. We go to. Oh, yeah. So up there it says proxy.golang.org. So whenever you have a program and you add dependencies, they are added to your go.mod file. And if you download those, if you do go get, either an explicit path or just go get anything that's being used in your program, the code will be downloaded. And it will be downloaded by default from this proxy. So Google runs this thing. And basically, when you ask it to get a certain piece of code, if it already has it, it gives you the code. If not, it will maybe go to GitHub or whatever, get the code, caches it, so the next time you can deliver it more quickly. I'll give you the data back, and you get to use the dependency. So that's usually pretty quick because it's all cached. And what they also have is a transparency log where they also keep hashes of all the code they downloaded. So if Google is distributing all these dependencies from all over GitHub and so on, we as users of Go, of course, want to know that the code we get is actually the thing that was published by whoever put it on GitHub. So they want to give us as users of Go trust that this is indeed the right code, and that's why they have this transparency log. So this proxy thing is a proxy with a cache, so you can download these dependencies more quickly, but it also has this something, which is an auditable checksum database, and then some long story, which has, if you click through there, here it's explained, a transparent log, and you can, so if you're interested in this stuff, then there's a whole nice technical explanation of how this works and how this basically makes sure that Google or the Go team cannot sneakily change whatever is in that cache. So we can trust, therefore, that what they give us as dependency is actually, as code, is actually what we requested when we get a certain dependency. So GoBuild actually uses the same code as the Go proxy, the Go module proxy uses. So the Go module proxy is for source code, and the GoBuild tool that I made is creating binaries out of that source code. So what you can do, you can see here. So basically what you do here is just like you use package.go.dev or godoc.org, you just type it in, you type the package that you want, you get a documentation. You can do basically the same thing here. You can just type in currently beta.gobuilds.org and type a module name after that, and it will fetch that code, compile it, and give you the binary. So there's actually different like URL schemes that you can use. So just the basic module, but you can also say I want a specific version, and then I want, now within a module you can have different packages, like multiple commands, like command something else. So I say binary, but the module can produce multiple binaries, of course. So I can select, if you want to, which one you want. Then you can also say I want it for maybe Linux or Windows, and then AMD 64 or ARM. And I want it built with a certain Go compiler toolchain, so the latest or maybe an older one. That's all possible. You can specify, but so this is just one example URL. At the bottom you can see where it's going. Just the base URL of the website plus the module that you want. You click on it, and it will return you, in this case, Linux AMD, because this machine is Linux. It will just detect what you're running on and give you the latest version of that module, the latest toolchain, and it will create this hash. You can download the file, and then you have the binary. Now, then there's some stuff here, some links, some commands about reproduce. You can reproduce the same thing locally, so you can verify that this is actually the sum you are supposed to get. And you can also click through to other versions. So you can say, I want an older version, or I want a Darwin macOS version, or I want with an older toolchain. So these highlighted in colored are the latest two supported version, the latest version of the major supported. But you can also select all the ones there. You normally don't want those, so I made them gray. But you can go here and see if this compiles. So now you can see here, it's building. Now we made it, and it added the hash of the binary to the transparency log. And now it's all stored, can never be changed. Well, let's go back home. So we can try a live demo if anyone has a command they made. There's some restrictions. It has to be pure Go, you cannot use CGo. And your go.mod file has to be up to date. If you have old dependencies, the build will fail. But if anyone has code that they are willing to, oh, Niels? No? If anyone, yeah, you need to know the URL.
I got one for you.
Okay.
github.com/koenbollen.
Oh, so it should be really big. So it's not Kubernetes, then it's
Koenbollen.
Koenbollen?
/xid.
XID?
Yeah.
This is a package that generates like a main, has a main? All right.
It's my biggest project now.
So, there it goes. Connection to backend failed.
You crashed.
What? I've never seen this.
The demo.
Oh wait, no, it's maybe it did crash. I don't know what's going on here. Live demos.
That was my plan all along.
There's a. I guess my machine where this is running now has DNS problems. Oh, no, I actually did test something this afternoon. Oh, there we're going to get even a bigger error. Anyway, normally this works, of course. Bummer. Let's go down here. There's more on this website. This description of the URLs. So finally, also redirected to the URL with the hash in it. So you can link to it from places, and you just download only that thing. If I would change the hash somewhere sneakily, well, you would have to go to a different URL. Let's see. Yeah, so the transparency log doesn't fit in a lightning talk, but it's a pretty clever thing, technical thing that basically just append-only log of hashes describing the code that belongs to the binary. Then now onto the caveats, the details. I only run Go build for your code. If you need tests, I'm not running it. I'm not running Go generate because that would run arbitrary commands. I'm not going to do that on my server. Sorry. There's no, you cannot select build tags or any. You cannot set like specific CPU instruction, like things like ARM versions that you might want to set. You cannot have any custom compiler and linker flags. You cannot have your make files, etc. Just only Go build, just the basic. That's why you want to write your Go in pure Go, so that this can build. What's also fun is that Go build automatically downloads the latest Go toolchain. So there's a JSON output on the Go website that lists the latest Go toolchains, and it's just a zip file. You download it and put it in a directory. So it's always this is hands-off. I don't update this. That's also why it doesn't work maybe. But this afternoon I could build something. But if a new release comes out, it just downloads the latest version and runs your code with it. And that's also one of the advantages. I'll come to that later. That's also fun. This one. So you ask it binary, creates it, gives it back to you, but I can configure this Go build to also go to other machines and also request that same binary, and then I can compare if they've all created the same binary, the same hash, and if not, something is wrong, and then I'm not trusting my builds because they apparently are not deterministic. And this is actually how I found a bug, or a bug. It's an issue with the toolchain, the Go toolchain, the compilers, that they would not generate the exact same binary in some cases, even though that was the plan of the Go team, and it had something to do with this. Concurrent compilation that was causing issues on multi-core machines. So that's why I disabled it for now, and then at least you get the same result, but they fixed it because they take this reproducible build stuff seriously. So that was cool. Anything else here that I need to say? Yeah, so there's a build ID in every Go binary that describes it's basically a hash of the source files that go into it, the flags, etc. It's pretty easy. You can usually cross-compile, it's also easy. But so when is it useful? In some cases you are creating tools and you want people to download those tools, also for Windows and macOS and Plan 9 and OpenBSD. And you don't want to create all those binaries all the time, it's a lot of work. So this can reduce the burden for you as a maintainer of software a bit. You just run one of these, and you say, this is my code. Whenever you tag a new release, you push it. I don't have to make binaries. You just always point to this latest page. People can go there and can generate the binary as they want. That's actually what it says here. There's no discrimination because you can build everything. So some projects, they don't release binaries for FreeBSD or OpenBSD, so that one user is now unhappy. But he can now keep everyone happy with this. This is, I think, a good one that you sometimes forget. If you write your code and there's a bug in it, you make a new release that fixes security fix, version 2.1. But of course, the Go toolchain also has issues. So that's why they release new point releases. But how often do people create new binaries? If they publish binaries, how often do they recreate their binaries with that new toolchain? I think oftentimes they don't because so for serious projects they do it, but it's if you publish binaries, it's just a lot of work to make new binaries for the same version of your software, but just built with a newer Go toolchain. So here it's just always the latest version. You get the latest bug fixes in the standard library as well. Yeah, and I think sorry. Yeah, it is. Yeah, that's true. That's true. But let's hope at least the point releases don't go too crazy. And at least if you want to have a binary, you don't have to wait for the people writing it to writing the software to release it. Yeah, I think that's pretty much what I wanted to show. There's this. It's open source. You can. I'm not doing it. It's not me. It's not me. No! Oh, wait, before it does something dangerous.
I think that is
Sorry.
Okay, questions.
There's a question there.
How much does the service cost you to run? Because you store a lot of data and things.
It's a good question. I don't actually have to store a lot of data because so I checked this afternoon just to see. This runs on a small virtual machine with 20 gigabytes of storage, and there's 3 gigabytes available. So it doesn't go for a long time still. But what I can do is just remove the binaries after I've created them. What I care about is having that checksum in the log. So I could just remove the binaries after 1 day, or maybe like 1 or 30 days after last time they were downloaded. And then if someone else requests them again, I can just recreate them, and they should be the same, because it's reproducible, it's the same binary. So I think I really only have to store the hashes for a long time, and everything else is temporary, I can just drop it.
Then where do you store the hashes in the transparency log?
Yeah, I store that on the machine, but okay. That's the hash is like 20 bytes for a hash, and then there's the path and the version. So there's just a line of 80 bytes or something for any build that I've done.
But you do pay for the compute power.
Yes. Well, it's a virtual machine, so it's okay. There's one machine, and if I could make a bigger one, but to be honest, no one's using this yet. So that does not matter too much. But if you would, if 10 people would build at the same time, they would have to wait a bit longer before they get their build.
It's all super interesting. Like, I'm just wondering, why doesn't Google run a service like this?
Yeah, that's a good question. I think it's in part because this is like a really nice, big, fat target for someone to hack into, right? This is handing out binaries, so you.
Same with the Go module
yeah,
proxy.
Well, actually, true. But I think it's a good question. I think this could be useful if there would be. So that's also like that was my question to you. Would you use this? I would be afraid to use it because this guy is claiming to. So there's this transparency log, but you have to check it. If you don't check it, you don't get the benefit. So there's a thing. So anytime you do go get, you basically just get the appended checksums. But if you download from this website, it's just a one-time thing. So that's why I have this example here. This go build command. If you do go build get, this just downloads the binary, but it also updates the locally stored, locally cached transparency log. And then if you do that, it verifies that no one has been meddling with it. But of course, it's far easier. That's why we love the internet. You click on links. Now I'm telling you, instead of doing this easy click the link thing, I'm telling you to run a command. Yeah, I could already just run go build. If you can do this, you can also build the code yourself. So the point is not very strong, maybe. But especially, for example, for internal company things, so you have people running your codes, and there's this one Windows user from accounting that can also use this guy. Yeah. Not sure how solid the argument is.
I just got a question. If, let's say, in the unlikely event that 3 lines of code doesn't compile, can you hand it a verbose switch that you can see what's going on?
I'm not sure how much it says, but I just do a regular go build in the end, and I do store the output of the command. We saw the failure just now. That was a failure to fetch the data with these but you'll get a similar thing. So you can also see the successful builds. So this recent build is all public. So this necessarily the transparency log means that whatever I build has to be public, because you have to be able to verify what is being added to the log. So this one was this afternoon, and I can just go to the build log and see I built with the verbose command. So you see all the low-level Go stuff that's happening. Maybe this is the problem, the big storage issue I may be having, the output of the of the log. But,
thank you.
Yeah.
Any other questions?
One small question. Have you considered running some smoke tests for a company who release command line tools, like compiling and using different platforms, and then automatically creating issues on GitHub, like why it is not working on OpenBSD? Yes.
No, but it's easy to point to build failures. You can just say, look, I want to have this binary, but it doesn't compile. Can I fix it? But I haven't done it yet.
Okay, I think that's it. Applause. Then, of course, as usual, we have presents for the speakers. And I see our American friend is leaving here, so I'm quickly going to give him a bar of chocolate. Just want to thank you for your talk. And 1 cup for Ilya, 1 cup for Koen. And you get a bar of chocolate. And Michiel gets a bar of chocolate. And now I don't have my speaker notes, but I'll keep it really easy. Thank you all for coming. The next meetup will be end of next month. Location to be determined. Probably going to happen. So we're still looking for speakers for next month. I think we can stay here until 10. Yeah. There's still maybe some drinks, some cold leftover pizza, whatever. Talk to each other, ask questions to the speakers, and see you all next month. And thanks to the host again, of course.